Going to solve a nice geometric problem. A circle of radius r semi circumscribes a hexagon ABCDEFA whose AB is equal to BC is equal to 1 semi, CD is equal to AF is equal to 2 centimeter and EF is equal to DA equal to 3 centimeter. We have to prove that this cubic equation 2r cube minus 7r minus 3 equal to 0, that is radius of the circle which circumscribes a hexagon satisfies a cubic equation. This cubic equation is 2r cube minus 7r minus 3 equal to 0, that is radius of the circle satisfies a cubic equation which is 2r cube minus 7r minus 3 equal to 0. Here we have drawn the figure. This is the circle which circumscribes this hexagon. This hexagon is A, B, C, D, E, F, A, and also the radius of this circle is given as r. So, and also we have considered O as the center of this circle. We have considered O as the center of this circle which circumscribes this hexagon. So, OC is equal to OB, OA is equal to OF is equal to OE is equal to OD are all the radii of this circle which is of length r, this is given. These are the radii of this circle. Now, here you can see that six triangles have been formed. 6 triangles have been formed. These triangles are OBC, OBA, OAF, OEF, OED and OCD. These are the 6 triangles which have been formed in this circle, in this hexagon. Now we consider 2 triangles, that is OBC and OBA. We can consider 2 triangles OBC and OBA. From these 2 triangles, from the triangle OBC and triangle OAB, we get OC is equal to OA. OC is equal to OA. Why? These are equal because these are the radii of this circle whose radius is r centimeter. So these are equal to r. These are equal. So OC is equal to OA. And also OB the common side. OB is the common side. OB is the common side. And also BC is equal to BA. BC is equal to BA, which are of length 1 centimeter, which is given. Length of AB and BC is 1 centimeter. Length of AB and BC, each of the length of AB and BC is of 1 centimeter, which is given. So BC is equal to AB is equal to 1. Now these 2 triangles, sides of these 2 triangles are equal to each other. That is, sides of OBC are equal to the sides of OAB. So by the law SSS, we can say that these 2 triangles are congruent to each other. So by SS law, we can write triangle OBC is congruent to triangle OAB. By the law SSS, side, we can say that these two triangles are congruent to each other. As this two triangle is congruent, so corresponding angles and corresponding sides are equal, and that is opposite angle of equal sides are equal. Opposite angles of equal sides are equal. So here BC, here OC, here angle side BC is equal to side BA, here side BC is equal to side BA. So their opposite angles are also equal because these two triangles are congruent to each other. So we can write angle OCOB is equal to angle BOA, and these two angles are considered as 2 theta, 2 theta considered. COB is equal to BOA, that is the angle subtended at the center. These two angles are equal, that is BOC is equal to BOA, as these two triangles are congruent to each other. So these are equal to 2 theta. Now we can consider the triangle OAB. Now triangle OAB is an isosceles triangle. Triangle OAB is an isosceles triangle. Triangle OAB is an isosceles triangle because OB is equal to OA. Two of its sides are equal. A triangle, two sides of it, if any two sides of any triangle are equal, then this triangle is called isosceles triangle. OAB has two sides, OB and OA are of same length, that is same length r, radius of this circle. So this triangle is called an isosceles triangle. So because OB is equal to OA equal to r, as OB is equal to OA is equal to r, that is two sides OB and OA are equal, then this triangle is called an isosceles triangle. So obviously these two angles are equal. The angle which are opposite to these equal sides are equal. Angle which are opposites to these sides are equal to each other. So opposite angles of OB is OAB. So we can say that OAB is equal to opposite sides of OA, opposite angle of sides OA is OBA. So OAB is equal to OB. As these two sides are equal, so this opposite angle of these two equal sides are also equal, and these opposite angles of these two equal sides are OAB and OBA, so they are equal. So OAB is equal to OBA. So these are equal to half of 180 degree minus 2 theta, because BOA is equal to 2 theta. So as these two angles are equal, so each of them is equal to half multiplied by 180 degree minus 2 theta, that is 90 degree minus theta. 90 degree minus theta. So we can apply the sine formula on this triangle. We can apply sine formula on triangle AOB. What is sine formula of a triangle? This formula is that the sides are proportional to the opposite angle of these sides, proportional to the sine of the opposite angles of these sides. Three sides of a triangle are proportional to their sine of their opposite angles, to the sine of their opposite angles, then this is the law sine formula. This is sine formula. What is sine formula? Sine formula is that the three sides of any triangle are proportional to the sine of their opposite angles. Proportional to the sines of their opposite angles. So we can write this sine, by this sine formula we can write AB over opposite angle sine BOA. This is the sine formula, is equal to OA over its opposite angle sine. OA opposite angle sine is OBA, sine OBA, is equal to OB sine of OAB. AB is considered as 1 semi. The AB is given as 1 semi. So 1 over sine BOA. Sine BOA is sine of 2 theta. BOA, value of BOA is 2 theta, is considered. So sine 2 theta is equal to OA. OA is the radius of the circle. So R over sine OBA. OBA is equal to 90 minus theta. We can write this equal to R over sine 90 minus theta. So 1 over sine 2 theta, 1 over sine 2 theta is equal to R over sine 90 minus theta, that is R over sine 90 minus theta. 1 over sine 2 theta is 2 sine theta cos theta by the formula of multiple angle. So sine 2 theta is 2 sine theta cos theta is equal to R over sine 90 minus theta. Sine 90 minus theta is equal to cos theta. So this is cos theta. This is cos theta. So we can write sine theta is equal to 1 over 2R. Here also cos theta not equal to 0, because theta cannot be 90 degree, that is 2 theta cannot be 180 degree. 2 theta cannot be 1 because BOA is 2 theta, and if theta equal to 90 degree, then 2 theta equal to 180 degree. Any angle of a triangle cannot be 180 degree. So cos theta not equal to theta not equal to 90 degree, that is cos theta not equal to 0. So sin theta equal to 1 over 2r. Now by the same way we can show that triangle OCD and triangle OAF are also congruent to each other by the similar manner, that is similarly we can prove that triangle COD is congruent to triangle AOF. Triangle COD is congruent to triangle AOF. By the same way we can show that COD is congruent to triangle COD is congruent to triangle AOF, as we have previously proved triangle BOC is congruent to triangle BOA. By the same way we can show that COD is congruent to AOF. So we can say that as these two triangles are congruent, so angle COD is equal to angle AOF. Angle COD is equal to angle AOF is equal to 2 phi considered. We can consider these two angles as 2 phi, and these two angles are equal because these two triangles are congruent to each other. We can prove it by the same way. Now we can take the triangle AOF. Now the triangle AOF is an isosceles. This triangle is also isosceles because AO is equal to OF is equal to R, because AO is equal to OF is equal to R. These are the radii of this circle. Then this radius is given as R. As these two sides are equal, then this triangle is called an isosceles triangle. So AOF is an isosceles triangle. As AO is equal to OF, so the opposite angle of these two sides are also equal. Opposite angles of the sides AO is OFA. So OFA is equal to opposite angle of the sides OF is OAF. These are equal, as these two sides are equal. So opposite angles are also equal to each other, and these two are equal OAF, and these are also equal to, each of them is equal to half of 180 degree minus 2 phi. This is equal to 90 degree minus phi. By applying sine formula on triangle AOF, we can write side AF over the sine of its opposite angles. Opposite angle is AOF. Sine of AOF is equal to side OA over sine of its opposite angles. Sine of its opposite angle is sine OFA. Sine OFA is equal to side OF over its sine of its opposite angles is OAF. Sine, this is the sine formula. Sine formula is that the three sides of any triangle are proportional to the sine of their opposite angles. So this is the sine formula. If AF is given as 2 centimeter, that is 2 over sine AOF. AOF is considered as 2 phi, that is sine 2 phi, is equal to OA. OA is considered as R. Sine OAF. OFA, sine OFA is equal to 90 degree minus phi, sine 90 minus phi. This is also equal to R over sine 90 minus phi. So 2 over 2 sine phi cos phi by the formula of multiple angle. Sin 2 theta is equal to 2 sin theta cos theta is equal to R over cos of phi, and also this implies sin phi is equal to 1 over R. Sin phi is equal to 1 over r as cos phi not equal to 0. Cos phi not equal. If cos phi equal to 0, then phi equal to 90 degree and 2 phi is equal to 180 degree. But this is a triangle, so any angle of this triangle cannot be 180 degree. So phi cannot be equal to 90 degrees. That is, cos phi cannot be equal to 0. So cos phi not equal to 0. This is. Now similarly we can also prove triangle DOE and triangle EOF are also congruent to each other. Similarly, we can prove triangle DOE and triangle EOF are also congruent to each other. That is, DOE and EOF are congruent to each other. We can prove it, and also by the same way we can prove that this triangle is an isosceles triangle because OF and OE are equal to R. These are the radii of this circle. So as these two sides are equal, so this triangle is an isosceles triangle. Now similarly we can prove triangle EOD congruent to triangle EOF. So as these two triangles are congruent, this can be proved easily by the same way, and as these two triangles are congruent to each other, so these two angles are equal. That is, angle EOD is equal to angle EOF are equal, and also these are considered as 2 psi. Considered as 2 psi, and also we can prove that triangle EOF is isosceles because these two sides are equal. OE and OF are equal, and these are equal to R. That is, these are the radii of these circles. As these two sides are equal, then this triangle is called an isosceles triangle because EO is equal to OF is equal to R. As these two sides of this triangle EOF are equal, then this triangle is called an isosceles triangle, and these two sides are equal, so their opposite angles are also equal. So opposite angle of EO is OFE. Opposite angles of OF is OEF. They are also equal. As these two sides are equal, so their opposite angles are also equal, OEF. And these two, each of these two angles is equal to half of 180 degree minus 2 psi, that is 90 degree minus psi. Also by applying Sine formula on the triangle EOF, we can write side EF over sine of its opposite angle is EOF. EOF is equal to sine OE over the sine of its opposite angles. Sine of its opposite angle is OE, opposite angle is OFE, sine of OFE is equal to OF over sine of its opposite angle is OEF. So EF is given as 3 centimeter. EF is equal to D is equal to 3 semi. This is given. So EF is 3 over sine EOF. EOF is considered as 2 psi. So this is sine 2 psi is equal to OE is considered as R, the radius of the circle. Sine OFE, OFE is 90 degree minus psi. Sine 90 minus psi. This is also equal to R over sine 90 minus psi. So 3 over 2 sine psi cos psi is equal to R over cos psi. This implies R is equal to 3 over 2R. Sin psi is equal to, this implies sin psi is equal to 3 over 2R, as cos psi not equal to 0, because if psi equal to if cos psi is equal to 0, then psi is equal to 90 degree and 2 psi is equal to 180 degree, but any angle of a triangle cannot be 180 degree. So this cannot be possible. So cos phi not equal to 0. Cos psi not equal to 0. As cos psi not equal to 0, so we can get sin psi equal to 3 over 2R. So we have got 3 results, that is sin theta equal to 1 over 2R, sin phi equal to 1 over R, and sin psi equal to 3 over 2R. We have got these 3 results, that is sin psi is equal to 3 over 2R. We have got these 3 results, that is sin theta equal to 1 over 2R, sin phi equal to 1 over R, sin psi is equal to 3 over 2R. Now we can write angle COD plus angle COB plus angle BOA plus angle AOF plus angle EOF plus angle DOE plus angle that is COD plus angle COB plus angle BOA plus angle AOF plus angle EOF plus angle DOE is equal to 360 degree, because these are 6 angles subtended at the center O, and sum of all of this angle is 90 degree. Sum of all this angle is 360 degree, because angle surrounding the point O is 360 degree. So this total of the sum total of these 6 angles is 360 degree. So we can write COD. COD is considered as 2 phi. COD is considered as 2 phi. So this is 2 phi plus COB. COB is considered as 2 theta. BOA is also 2 theta. AOF is considered as 2 phi. EOF is considered as 2 psi, and this is also 2 psi is equal to 360 degree. So we can write theta plus phi plus psi is equal to 90 degree, is equal to 90 degree. So theta plus phi is equal to 90 degree minus psi. Theta plus phi is equal to 90 degree minus psi. Now we can take both sides cosine. We can take cosine on both sides. So cos theta plus phi is equal to cos of 90 degree minus psi. By the formula of composite angle, that is cos theta plus phi is cos theta cos phi minus sin theta sin phi. So we can write from the formula of composite angle, which is cos theta cos phi minus sin theta sin phi, and this is also sin psi. Cos 90 minus psi is sin psi. Now cos theta sin theta is 1 over 2r, so cos theta is equal to square root of 1 minus 1 over 2r square, that is 4r square. Cos phi, sin phi is 1 over r, so cos phi is equal to square root of 1 minus r square, minus sin theta is 1 over 2r, sin phi is 1 over r, sin psi is equal to 3 over 2r, 3 over 2r. Now we can simplify this. After simplification we get 1 over 2r multiplied by 1 over r multiplied by 4r square minus 1 r square minus 1 minus this is equal to this, and we can factorize this expression. After factorization we get 1 over 2r multiplied 1 over r root over of 4r square minus 1 root over of r square minus 1 minus 1 is equal to 3 over 2r. We have got this. So we can write root over of 4r square minus 1 multiplied by r root over of r square minus 1 is equal to 3 over 2r multiplied by 2r multiplied by r, and these 2r are cancelled out, so this is equal to 3r. So square root of 4r square minus 1 root over of 4 square root of r square minus 1 multiplied by square root of r square square root of 4r square minus 1 multiplied by square root of r square minus 1 is equal to this is equal to minus 1 is equal to 3r, so this is equal to 3r plus 1. Now we can square of both sides of this equation. We can square both sides of this equation. We can take the square of both sides of this equation. After squaring we get squaring both sides of equation 1, we get 4r square minus 1 multiplied by r square minus 1 is equal to 3r plus 1 square. After squaring the both sides of this equation, we get this 4r square minus 1 multiplied by r square minus 1 is equal to 3r plus 1 whole square. Now we can multiply these two terms. After multiplication we get 4r4 minus 5r square plus 1, and we can expand the square and after expanding this square we get 9r square plus 6r plus 1. These ones are cancelled out, so 4r4 minus 14r square plus a minus 6r equal to 0. Now you can factorize this expression. After factorization we get 2r multiplied by 2r cube minus 7r minus 3 is equal to 0. So 2r cube minus 7r minus 3 equal to 0, as 2r not equal to 0, as 2r not equal to 0, because r is the radius of this circle, so radius cannot be 0. So 2r not equal to 0, so this is equal to 0. This is the result. We have to prove this result. We have to prove 2r cube minus 7r minus 3 equal to 0. Thus we have proved this result, that is 2r cube minus 7r minus 3 equal to 0, that is radius of this circle satisfies a cubic equation which is 2r cube minus 7r minus 3 equal to 0.